So you want to know if a number is divisible by 13. You could, of course, just do the long division or, pull out your phone, but honestly, where's the fun in that? That's the boring way. In this explainer, we're going to crack the code on a much more interesting, way more elegant strategy. Okay, let's just jump right in with the question. Look at this number, 1,234. Is it a multiple of 13? Now, by the end of this, you're going to be able to solve this pretty much in your head. No calculator needed. So really, we have two paths we can take here. On one side, you've got the standard way you probably learned in school. And look, it works, but it's a bit of a grind. But on the other side, there's a more elegant way, a really simple trick that doesn't just give you the answer, but kind of shows you a little something about the beautiful patterns hidden inside numbers. Let's take the elegant path. Here's how we're going to break it all down. First, we'll look at a new way to think about numbers. Then, I'll show you the add 4 times rule. After that, we'll put that rule to the test with some real examples, uncover the math that actually makes it all tick, and finally, we'll zoom out and look at the bigger picture. All right, section 1. So before we can even get to the trick itself, we just need a super simple way to split any number into 2 parts. And this concept right here is the key. It looks a little mathy, but it's actually really straightforward. Any whole number, let's call it n, can be broken down just like this. We just take the very last digit, we'll call that f, and we separate it from y, which is, it's just everything else. So any number is just 10 times y plus f. For instance, let's take the number 247. Here, the final digit, our f, is just 7. And the rest of the number, our y, is 24. See? Simple. So 247 is really just 10 times 24 plus 7. This is the only idea we need to get started. And with that little bit of groundwork laid, we are ready for the rule itself. It's a really neat little process I like to call the add 4 times rule. And here it is in just 3 steps. First, you do exactly what we just practiced. You split the number into y and f. Second, you calculate a new, smaller number using this little formula, y plus 4 times f. So that's the rest of the number plus 4 times the last digit. And third, if your new number is still a bit too big to tell, you just do it again. You just keep repeating the process until you land on a number that you know is or isn't a multiple of 13. Okay, theory is one thing, but let's see how this thing actually performs in the wild. It's time to put the rule to work. Let's go back to our friend 247. We're going to use our new rule to see if it's divisible by 13. Okay, step 1. We split 247 into y equals 24 and f equals 7. Now we just plug it into the formula, y plus 4 times f. That's 24 plus 4 times 7, which is 24 plus 28. And that gives us a brand new, much smaller number, 52. Now maybe you already know that 52 is 4 times 13. But hey, if you don't, no big deal. We just repeat the process. For 52, y is 5 and f is 2. So we do 5 plus 4 times 2, which is 5 plus 8, and that gets us to 13. Well, since 13 is definitely divisible by 13, it means our original number, 247, has to be as well. Pretty slick, right? All right, that was a good warm-up. Now, let's get back to that question from the very beginning of our explainer. Is 1234 divisible by 13? Let's run the rule. For 1234, y is 123, and f is 4. So we calculate 123 plus 4 times 4. That's 123 plus 16, which gives us 139. Okay, a much simpler number, but maybe we're still not sure about it. So we just go again. For 139, y is 13 and f is 9. We calculate 13 plus 4 times 9. That's 13 plus 36, which equals 49. Now, is 49 a multiple of 13? Nope, not even close. And here's the key. That means our original number, 1234, isn't divisible by 13 either. The rule tells us yes, and it tells us no. So we've seen how it works, but now we get to the really fascinating part, the why. Why on earth does this little mathematical sleight of hand actually work? Let's take a peek at the math behind the magic. To really get the proof, we need a concept called modular arithmetic. Now, don't let the name scare you off. It's just a fancy term for the math of remainders. When we write that expression you see on the screen, A is equivalent to B mod 13, it just means that A and B have the exact same remainder when you divide them by 13. That's it. So for us, saying n is divisible by 13 is just a different way of saying n has a remainder of 0. And this is the proof. Now, don't worry about trying to read every single symbol. Let's just walk through the big idea together. We start with our number n equals 10y plus f. Now, the secret move is to multiply the whole thing by 4. Why 4? We'll see in just a sec. That gives us 4n on one side and 40y plus 4f on the other. And here is where the magic of modular arithmetic comes in. When we're only paying attention to remainders after dividing by 13, the number 40 acts exactly like the number 1. So we can just swap out 40y for a plain old y. This proves that 4n has the same remainder as y plus 4f. And since multiplying by 4 doesn't change whether something is divisible by 13 or not, it tells us for sure that our original number n is divisible by 13 if and only if our new, simpler number, y plus 4f, is too. So the entire trick, the whole thing, hangs on this one amazing little fact. Because 10 times 4 is 40, and 40 leaves a remainder of 1 when you divide by 13, that number 4 essentially undoes the 10 in the world of mod 13. It's what's called a multiplicative inverse, and it is the secret sauce that makes this entire rule work. And here's a fun little aside. In this world of mod 13, adding 4 is the exact same thing as subtracting 9. So you could totally use an alternate rule, y times minus 9 times f. It would work perfectly every single time. But let's be honest, adding 4 is almost always going to be easier in your head than subtracting 9, right? So we just stick with a simpler version. So let's zoom out for a second. This neat little process is more than just a party trick for the number 13. It's really an introduction to a completely different and really powerful way of looking at the world of numbers. And this quote really says it all. Our rule works because we're just replacing a big number n with a smaller one, y plus 4f, that basically tells the same divisibility story. And that's the power of modular arithmetic. By ignoring everything but the remainder, we can find these incredible hidden patterns. It's a tool used in everything from cryptography to computer science. And you know, all this talk about 13 kind of makes you think about the number itself. Beyond its math properties, 13 has this really unique spot in our culture. From the whole unlucky thing to the idea of a baker's dozen, it just goes to show you that numbers aren't just symbols. They're actually woven into our history and our stories. And this really leaves us with a final thought. We've just uncovered one elegant little rule that was hiding inside the number 13. It really makes you wonder, doesn't it? What other mathematical tricks, what other beautiful patterns are just sitting out there, hiding in plain sight, just waiting for us to find them?